What is this? That's my power supply. We have a new circuit here. I think it's not new. This is my modified version of my transistor as a switch in a collector side. Push the button, switch on, kill the light. Push the button, the switch, the LED turns on. Push the button, the LED turns on. So this is transistor as a switch, modified version of my previous switch, which has a reverse voltage or leakage current happening. Let us see the circuit. So this is now my modified circuit. Same voltage supply here, 5 volts to the pull up resistor. I put pull up resistor here, or at the same time that this is not a pull up resistor. This is a current limiting resistor of the LED, and the transistor 2222A is also, there is a pull down resistor here and a base resistor here to protect the transistor and the push button. I computed all the values of the resistor here, and let us check. This is my new. What we have here is the old one. The old one, the pull down resistor is connected here. Now I place the new pull down resistor here. Computing for the RD, simple as Kirchhoff's voltage loop, my favorite magician. Voltage supply minus voltage drop across the resistor of the LED, voltage drop across the LED, voltage drop of the transistor, collector to emitter in saturation, voltage drop across the pull down resistor. Computing all of them, we've got here minus, 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 and as long as the push button is open, we've got a current flowing also here. There is a breakdown voltage, base is open, breakdown current, that is 10 milliampere. There is a 10 milliampere flowing here when still the push button is open. That's the cause of the leakage current. We need to compute for the values of the resistor to drop that leakage current when the push button is open. So we compute the value of the voltage using voltage Kirchhoff's loop here, my favorite magician, and we've got the voltage drop here, which is 0.3 volts plus voltage drop of the diode is 2.3 volts. The two components, 2.3 volts. So the voltage drop of the resistor here is just the minus of the voltage supply minus the voltage drop of the two components. It becomes 2.3 voltage supply minus 2.7. That is the voltage drop of the two components. See, and now we going to divide that voltage here, which is 2.7 divided 2.3 now. See, divided by 1.15 divided by 2, 1.15. So 1.15, 1.15, 2 volts, 0.3 volts is equal to 5 volts. They are in parallel. Computing null value of RD, voltage drop of 1.15, and the current is 0.01 ampere. I'm using 0.01 ampere, that is the reverse voltage happening when the base is open. It's in the data sheet. This one, collector emitter breakdown voltage 10 milliampere when the base is open. That is the characteristics of 2228 transistor. We got the 1.15, the voltage drop across RD, and the 0.01 ampere, 10 milliampere breakdown voltage current, collector current. Now we got 150 ohms, that is the value of RD when the push button is at open or it has a logic 0. And RSO also the same computation, same, since we divide the voltage here to balance the circuit. And to calculate the base resistor, magic formula of the transistor, now you need to push the button. So the push button is now closed. During the state of logic 1 or closing the push button, the transistor will now conduct. So using the collector current now is 20 milliampere, which is also equal to the forward current of an LED. We need to saturate that transistor 20 milliampere here. So when you push the button, current flows here and here. The current flowing here is 20 milliampere. That is what we need to saturate this transistor, or to operate this transistor in saturation mode. So transistor magic formula, HFP is IC over IB. IB is also equal to the I current across the base resistor. Now equal to the 0.02 ampere, that is the key current flowing in saturation mode, or the push button is closed, divided by 100. HFE as a magic formula of transistor. HFE current gain 100 is in the table here. It's 100 operating across 150 milliamps. The range of IC is equal to 150 milliamps. We have 20 milliampere needed to conduct the transistor in saturation. That's along 100 HFP. So we got a base resistor current of 0.002 ampere. Kirchhoff's voltage loop here to compute the voltage here. There, voltage supply minus voltage drop of base resistor, voltage drop of base emitter saturation. We have here base emitter saturation voltage of along 150 milliamps at the range of 0.6 volts. We have 0.6 volts drop here at the transistor, and the voltage drop of the RS, or the pull down resistor. We now know the voltage supply. We don't know the voltage of the base resistor. We know the voltage drop here and also the voltage drop here. We get here PS minus BESAT minus BS 5 minus 0.6 base emitter saturation. Conduct the transistor in saturation mode, or minus 1.15. that is, we already have 1.15, 3.25 volts voltage across the base resistor. Now Ohm's law, my favorite magician, using 3.25 here, 0.0028 ampere is flowing when we use the current 0.02 ampere when the push button is closed. 20 milliampere now is flowing when the push button is closed. Unlike the previous one, when the push button is open, we have a value of resistor here. Also, when the push button is closed, we got a value of resistor that is 17,000 ohms or 17.2 kilo ohms, my available resistor. Since we are operating in a push button is closed, we're now using 0.02 ampere here, the forward current of the LED, to pass to the transistor conducting in push button is closed, or in logic 1, inputting a signal 1 here, conducting the transistor saturation mode, current of 20 milliampere using 0.02 ampere or 20 milliampere, and the voltage drop of the resistor diode is 1.15. We got now a new value of 57.5 ohms when the switch is closed, or logic 1. We got a new value of 57.5 ohms when the switch is closed, and we get a new value of RS 57.5 ohms, same as here, when the switch is closed. But when the switch is open, the RD is 150. When the switch is closed, RD is 57.5. When the switch is open, RS or pull down resistor is 150. When the switch is closed, it's 57.5 ohms. So I will still using this resistor value 150 and 150, not this one.